AI in search, from keywords to meaning. Welcome to Localization News You Can Use, your daily dose of localization know-how. Today, we're exploring a monumental shift in how we think about language, data, and the very fabric of digital communication. Forget everything you thought you knew about search boxes and translation memories, because the ground is moving beneath our feet. What if your translation memories could predict what you need next, like a recommendation engine for language? What if your meticulously curated glossaries became the powerhouse behind your entire search infrastructure? And what if your localization team was pivotal in crafting the next generation of enterprise AI? This isn't science fiction, it's the unfolding reality, powered by some seriously clever technology. We're witnessing the twilight of traditional keyword search. You know the drill. Type in a few words, cross your fingers, and sift through the results. But user expectations have skyrocketed. We now expect to converse with our search tools, to express complex intentions, and to be understood, irrespective of the language we use or the nuances we imply. At the heart of this revolution are vector embeddings, a fascinating way of representing meaning that's allowing machines to leapfrog simple string matching and grasp context, intent, and even sentiment across languages. It's about moving from rigid, brittle systems to flexible architectures where multilingual content isn't just stored, but intelligently retrieved, recommended, and repurposed based on what users truly mean. So, how does this magic work, especially when it comes to navigating the beautiful complexity of multiple languages? Well, historically, translation technology often relied on finding identical or very similar strings of text. But language is so much richer than that. Idioms, cultural subtleties, sarcasm. These are things that a simple one-to-one lookup just can't handle. Vector embeddings change the game by encoding text into a multidimensional space where meaning, rather than the sequence of characters, dictates proximity. Think of it. Buenos dias and good day might look different, but they'll cluster together in this vector space because their underlying meaning is the same. This works across languages, creating a shared space where concepts align. Consider how different cultures describe the same thing. In Dutch, the middle traffic light is orange, not yellow, as in English. In Japan, the word traditionally meaning blue is used for green traffic lights. Embeddings learn these associations from vast amounts of real-world text, allowing them to capture these culturally dependent meanings in a way older models never could. It's about representing meaning fluidly, which is a massive advantage for any global system. You no longer need to translate everything first just to make it discoverable. You just need the system to understand what it means. This capability transforms how we approach language operations at scale. Instead of building separate search systems for German, then Arabic, then Spanish, imagine a single unified vector space. This space understands the relationships between all your content, regardless of the original tongue. Someone could search in Japanese, and if the most relevant information is in a Portuguese document, the system can still find it based on this semantic similarity. This isn't just an improvement, it's a fundamental architectural shift. We're moving away from fragmented workflows towards a centralized infrastructure where meaning and intent are paramount. Language data, in this model, becomes an incredibly strategic asset. The more multilingual content you have, the more powerful this semantic layer becomes, connecting everything without the need to juggle countless files and databases for each language. Now, you might be wondering how this relates to other sophisticated data structures like knowledge graphs. Are they rivals? Not at all. They're actually fantastic partners. Embeddings excel at understanding the nuance in a complex query. They get you into the right conceptual neighborhood. Knowledge graphs, on the other hand, are brilliant for navigating structured, explicit relationships. They can tell you exactly what's on each street in that neighborhood, tracing clear paths between known entities. In fact, many cutting-edge vector search algorithms are themselves graph-based, creating a kind of best of both worlds scenario, flexible semantic search combined with structured, explainable reasoning. Let's make this more concrete. Where is this technology already making a difference? E-commerce and hospitality are seeing huge benefits, particularly in recommendation systems. Imagine you're a new user on a shopping site and you type in a very specific request, say a t shirt with stripes and a mandarin collar. Even if that exact item doesn't exist, an embedding powered system can instantly find stylistically similar items by mapping your request into its vector space. This happens in milliseconds. It also elegantly sidesteps the old out of vocabulary problem. New terms or product descriptions can be understood relative to existing ones because the system focuses on meaning, not just pre existing keywords. And what about all that messy, unstructured data that businesses accumulate? PDFs, emails, support logs in various languages? Advanced systems can now create meaningful embeddings from all these diverse sources, making previously siloed information part of a single searchable ecosystem. This leads directly to a much richer, more nuanced level of personalization. Embeddings can encode not just the words of a query, but also factors like user location, if relevant and permitted, the recency of information, and even specific business priorities. Want to highlight a new collection this week or prioritize certain features? The system can be tuned to adjust how it interprets similarity. This is a world away from the often clunky personalization of older systems, which might rely on broad user segments or IP address lookups. If you're someone who operates across borders, speaking multiple languages, you've likely felt the frustration of search results being overly skewed by your current location. Embedding-driven systems can capture your true intent, like searching for Belgian news in French while you're physically in Texas, and deliver relevant results without you needing to wrestle with advanced settings. The aim is a search experience that feels like a natural conversation, adapting to how people really think and speak. If you're thinking this sounds like a massive, disruptive overhaul, take heart. Adopting these embedding based systems can be an iterative process. You don't need to rip out everything that's currently working. Many organizations start by applying this technology to a single product category or one recommendation carousel and use A/B testing to compare performance against their existing KPIs, conversion rates, add to cart numbers, and so on. These systems are often modular, allowing for gradual introduction and building trust within teams. It's about evolution, not revolution. Looking ahead, the trajectory is towards what some are calling a vector native way of thinking. This isn't just about text anymore. It's about representing meaning across images, audio, structured data, essentially any way humans communicate, and doing so in a way that's tailored to the specific type of data. Imagine systems that can use a mixture of encoders, generating highly nuanced representations, whether it's processing product metadata, an email, or a photograph. The goal is an infrastructure that is industry agnostic, language agnostic, and format agnostic, allowing businesses to work with all their data cohesively. For localization professionals, this is a profound and exciting moment. Language is no longer just content to be translated, adapted, and published. It's becoming a fundamental part of the digital infrastructure itself. The question shifts from, how do we translate this, to how do we prepare this content so an AI system can truly understand and use it? The deep expertise in terminology, context, and tone that defines the localization field is more valuable than ever. It's about structuring meaning so that machines can work with it intelligently across languages and domains. Linguists are becoming the stewards of meaning in this new landscape, their skills embedded into the very architecture of next-generation AI. The future of localization won't be defined by how perfectly we replicate strings of text, but by how brilliantly we encode and enable meaning. Thank you for listening to this episode of Localization News You Can Use, your daily dose of localization know-how.